Sorry, because now I have to close this and it's easier. Okay. Okay, it's up to you. I give you, okay. If you prefer, I don't know if you want to like. Okay. Oh, yes.
Yes, that's easier. Thank you. Buongiorno. Gentili signore e signori, è un piacere di stare qui oggi a Modena e voglio ringraziare gli organizzatori della conferenza per l'invito a presentare un discorso keynote. Ma dato la mia conoscenza della lingua italiana è molto limitata, vorrei passare alla lingua inglese.
Thank you.
Yes, okay. So the title of my presentation is Learning Design, Creating Powerful Technology-Supported Learning Environments. And my PowerPoint is much less sophisticated than the one of Professor Delgado, because neither me nor most of you are native speakers of English. I put my full text on the PowerPoint. The interest in learning and how to influence it has been around throughout the history, the total history. For instance, in this country, Seneca and Quintilianus wrote about it already in the 1st century. And the scientific study of learning, however, only started in the beginning of the 20th century, especially, for example, with Thorndike as one of the pioneers of the field. During the 20th century, several perspectives of learning succeeded each other, from behaviorism, Gestalt psychology, cognitive psychology, and constructivism. But overall, notwithstanding high expectations throughout the 20th century about the potential of the scientific study to improve learning and teaching and educational practices, the relationship between research and practice remained a rather awkward and not very productive one in this century. The situation started to change in the last decades of the 20th century due to the emergence of the learning sciences, a new interdisciplinary field based on research emanating from a variety of disciplines like cognitive science, computer science, educational psychology, philosophy, sociology, anthropology, and applied linguistics. And I want to refer you here to this booklet that has recently been published in Italian about Le Scienze dell'Apprendimento for a good introduction, and the main editor is Beatrice Ligorio. But I also like to refer you to a very recent book that appeared just a few months ago, Reflections on the Learning Sciences, which is a very impressive review of what has happened in this field. So the learning sciences aim at better understanding of learning in different educational situations, real-world situations. It may be the classroom, it may be the workplace, the family, or also in formal environments like learning in a museum. Researchers in the learning sciences apply a variety of methodologies, from experimental and quasi-experimental methods to also qualitative approaches. And important from an educational perspective is that they engage in design-based research, focusing on the development and evaluation of innovative learning environments, and by so doing, contributing or trying to contribute to improvement of educational practices. So here you have again the slides about the two books. And the pursuit of innovative educational practices was supported by rapid changes in society in the second part of the 20th century, namely the development of the so-called learning society. It has repeatedly been observed that education has not been able to keep up with the changes toward a learning society, and this has raised a challenge and growing need to reform education in view of preparing the future generation for the learning society and for today's technology, complex, economically world. The acquisition of high literacy skills is essential, like solving problems, creative thinking, communication skills, and so on. And interestingly, the interdisciplinary research in the learning sciences has and still does substantially contribute to meet this need for the new environments for learning by developing and elaborating new perspectives on the goals, the objectives of education, as well as on the nature of learning in schools, learning to achieve these goals in schools. And here is an overview of my presentation. I will first discuss a little bit this perspective on the goal of education and the nature of learning. Then, against this background, I will discuss the current state of the art of the use of technology for learning in today's classrooms, its shortcomings, and the needed directions for change in the future. Then I will discuss what I call an example of a learning design, namely a design experiment in which technology was used productively in 5th and 6th grade classrooms of the primary school in the format of a computer-supported collaborative learning environment. And I had also prepared something about the latest cutting-edge technology, namely the MOOCs, but due to time restrictions, I will not be able to go into the details. But I can say that my perspective is very much in line with what Professor Delgado has discussed, so I can easily skip it, I think. So the first thing is the goal of education and the future and the nature of productive learning. Traditionally, educational psychologists were focused on how to pursue and achieve the objectives of education, but less interested in determining these goals. Well, this has changed. The learning scientists discovered that the challenge of educational reform required considering also those objectives, and that there is a need for a shift from the traditional focus on learning and teaching, on the transition of surface knowledge toward the acquisition of deep conceptual knowledge on the one hand and learning and thinking skills on the other hand. And adaptive competence is, in my opinion, or can be considered as the ultimate goal of education. In a report of the European Round Table, today's learning society is defined in the following way, and this is a quote: "Learning is accepted as a continuous activity throughout life. Learners assume responsibility for their own progress. Assessment is designed to confirm progress rather than to sanction failure. Personal competence and shared values and team spirit are recognized equally with the pursuit of knowledge, and learning is a partnership among students, teachers, parents, employers, and the community working together." Well, taking this into account, it is obvious that education at all levels must focus more than has been the case in the past on developing and fostering in students what I call adaptive expertise, adaptive competence, which I define as the ability to apply meaningfully learning skills, knowledge, and skills flexibly, creativity in a variety of contexts, which is opposed to what I call routine expertise, in line with Hatano, the ability to complete typical school tasks quickly and accurately, but often without much understanding and with what is behind it. And what is adaptive competence? Well, adaptive competence, in my opinion, taking into account the research on expertise, is today fairly broadly considered as achieving the acquisition of different cognitive, motivational, and affective components, And I have listed 5 of them here: a well-organized and flexibly organized domain-specific knowledge base, the knowledge of a field; heuristic methods, which are search strategies for problem analysis and transformation, which do not guarantee that you will find the solution of a problem, but will improve the chances that you will achieve it because of taking a systematic approach to the problem. Next, we have meta-knowledge, which involves 2 aspects: knowledge about one's cognitive functioning, metacognitive knowledge, but also knowledge about one's motivation and emotions that can influence learning. So these affective aspects are much more considered today. And the same is true for the 4th component, namely self-regulation skills, where we also have skills for regulating your own processes, cognitive self-regulation, for example, reflecting on a solution process, planning a solution process, and so on. Skills for regulating one's motivation and emotional processes, which I call motivational self-regulation. For example, being able to maintain attention and motivation to solve a given problem and not giving up too fast. And finally, positive affect, which are related, which involves positive emotions and attitudes toward subject matter domains, toward also learning as a process, and also self-efficacy beliefs. And that's for adaptive competence. And to achieve adaptive competence, you need to use a constructive learning approach as the road to it. And to pursue this, in taking into account the importance of contextual and social factors that affect learning, contemporary school learning should embody, more than was the case in the past, the current prevailing perspective on learning as an active constructive, a cumulative, a goal-oriented, a self-regulated, a situated and collaborative, and individual different process of knowledge and skill building. And I think that these features of productive learning, meaningful learning, are well documented by a substantial amount of research in the learning sciences today. And here you see a few references. And therefore, they can and should guide educational practices. The constructive perspective on learning has also been questioned. It has been criticized by authors who still argue in favor of direct instruction. But if you look at the literature, based on an analysis, for example, of the literature of the past 50 years, Rich Mayer has concluded that guided discovery or constructive learning leads to better learning results than direct teaching. And, however, the learning environment should be characterized by an effective balance between, on the one hand, discovery and personal exploration, and on the other hand, a systematic instruction and guidance. And the balance between the two can shift and change depending on the progress of the children. And of course, you also have to take into account the individual differences in abilities, needs, and motivation. So having said this on my conception of the goal of education and the process of education, of learning needed to get there, I now want to turn to technology-supported learning and give a brief state of the art, of course, a bit limited on based on some literature. The use of technology for education goes back about a century ago when Thomas Edison predicted that the motion picture would revolutionize education and make books obsolete in schools. The revolution did not occur. The next cutting-edge technology, the radio, evoked similar high expectations, as is illustrated by the following quote from a 1932 book entitled Radio, the Assistant Teacher. And what is the quote? The central and dominant aim of education by radio is to bring the world to the classroom, to make universally available the services of the finest teachers, the inspiration of the greatest leaders. However, the radio also has never made it in education. And the same happened and is true for its successors. the school television in the 1950s, programmed instruction in the 1960s, big promises, but ending in a blind alley. The latest cutting-edge technology, the computer and ICT, emerged in schools in the 1980s and rose even higher optimism and expectations than the predecessors. But again, so far these expectations have not only partially materialized and not fully materialized, and the conclusion of the well-known historian of education of Stanford University, Larry Cuban, in 2001 still is true, in my opinion. And here is the quote: "The introduction of information technologies into schools over the past 2 decades has achieved neither the transformation of teaching and learning nor the productive gains that a coalition of corporate executives, public officials, parents, academics, and educators have sought." In this respect, it is interesting to mention some results of the Survey of Schools, ICT and Education, benchmarking access, use, and attitude to technology in Europe's schools, commissioned by the European Commission and published in 2013. The survey was done in 31 countries and provides a rich image of the situation in Europe, which maybe have a little bit changed since then, but at least 2013 is not too long ago. And here follow a small selection of average findings, and one should take into account, of course, that there are often very large differences between countries. 3 interesting concepts that they use in the presentation of the results are digitally supported schools, digitally confident and supportive teachers, and digitally confident and supportive students. Let me start with digitally supportive schools. Have policies about ICT integration in teaching and learning, and provide concrete support measures such as teacher professional development, provision of ICT coordinators. On average, only 25 to 30% of students in European countries are in such schools. And I must say that in the survey, Italy scores below average. For example, here you have what's happening in grade 4, and you see that Italy is pretty much at the bottom of the list. Where is
Yes,
mine?
is that?
Yeah. So that's in grade 4. When we go to grade 8, you see the whole list of countries. And of course, the 25% here is in the middle. This is grade 8. And again, oh, sorry, that's too fast. Here, Italy is very much at the bottom, as you see. Yes. So there is room for improvement, I would say. When we speak about digitally confident and supportive teachers, how are they defined? They have high confidence in their own ECT skills. They have positive beliefs about ICT use for teaching and learning. And they have easy access to ICT infrastructure at their school. In the countries involved in the survey, on average 20 to 25% of the students are taught by digitally confident and supportive teachers. This is quite low, and Italy scores close to this average in grades 4 and 8, but below the average in grades 11 in general, as well as vocational education. Based on these observations, the survey rightly concludes these findings, and this is again a quote, "These findings pave the way for strongly recommending to policymakers at central, national, regional, local, and school level to massively invest in teacher professional development as a necessary accompaniment to investing in school ICT infrastructure." Another complementary recommendation in this context by the survey is that policymakers should dedicate attention to the creation and dissemination of good quality learning resources with the aim of increasing their use by teachers and students during lessons. One can argue that in the past decades, the introduction of technology in schools was not managed appropriately by a good business model. From the 1980s, computers were massively installed in schools, but the money was massively used for hardware, whereas good software was often lacking. In accordance with the recommendations of the survey, the European survey, to make change, and that has been my argument since the 1980s, to make a change to be successful in applying ICT in education, as a rule of thumb, only 1/3 of the resources should be spent on hardware, 1/3 on the development and dissemination of high-quality software, and 1/3 on training teachers in the appropriate application of ICT for teaching and learning. So that's my recommendation. They're digitally confident and supportive students. Well, they have high access to and use of ICT at home and at school. The survey revealed that on average 30 to 35% of students in Europe are digitally confident and supportive students. Italy approaches this average in grades 8 and 11 in general education, but scores below average in grade 11 of vocational education. One can conclude that also here there is substantial space for some improvement. In sum, up to now, the situation of ICT use in schools largely confirms Cuban's conclusion of 2001. And so, one of the conclusions of the survey is, and this is a quote again, there is still a long way to go before ICT permeates schools and teaching. A few other interesting observations reported in the survey are the following. No overall relation was established between high levels of computer availability and the frequency of use by the teachers. So more computers is not a sufficient condition for their use. Although teachers have been familiar with ICT for learning and teaching for some years, they often find it difficult to apply ICT into their teaching. And in this respect, they need ongoing support, technical, but also pedagogically. Also, for example, by ICT coordinators. The current situation raises the question about the reason for the successive failures of technology applications to education. And the main answer to this lies in the lack of good dialogue and especially the persevering conflict between two very different approaches to learning with technology. On the one hand, the technology-centered versus the learning-centered approach. And what is the difference here? Well, the technology-centered approach, there the computer is just an add-on to an existing classroom situation without much concern about how the human mind works and how students learn effectively. They add a computer to a situation that for the rest is not very much changed. And the learning-centered approach focuses on how students learn. Technology is conceived as an aid to support for learning, integrated and adapted to the learning environment that fits the needs of learners and teachers. This indicates at the same time the direction to go for research and development that aims at contributing to the improvement of classroom practices by designing powerful computer-supported learning environments. And the next section discusses an example of an intervention study that follows these directions. The study aims at the development of a powerful computer-supported learning environment for math problem solving and is based on the perspective on the goals of education and the nature of learning that I have reviewed above. Because of the focus hereby is on learning rather than on teaching, this approach should be called, in my opinion, learning design rather than instructional design. And I refer here also to the work of Diana Laurier from London School of Education, who is in favor of that approach. Well, here is then the presentation of this computer-supported collaborative learning environment for mathematics problem solving. The background of that is that a computer-supported learning environment designed that facilitates the distributed learning of problem solving but also problem posing, so problem generating by students themselves. In upper primary school, we worked in the 5th and the 6th grade. In doing so, 2 strands of theory were combined and integrated, and these 2 strands of art on the first line was a metacognitive aspect of collaborative knowledge building supported by knowledge forum, a series of tools for constructing and storing notes, for sharing notes and exchanging comments on them, and for scaffolding students in their acquisition of specific cognitive operations and concepts. We refer here to the work of Marlene Scardamelia and Karl Bereiter of the University of Toronto. The second strand is intervention research focused on the development in students of a genuine mathematical problem-solving skills approach in line with the view of constructive learning that I reviewed before. Combining these 2 strands of theory and research resulted in a learning environment wherein students, under the guidance of the teacher, their regular teacher, and using knowledge forum, learned collaboratively to solve and pose math problems, to communicate about and reflect on their problem-solving processes, and starting thereby from a shared description and multiple comments on the solution process. The study also intended to elaborate an effective strategy to guide and support teachers in the embedded appropriate use of the cognitive technological tools in their teaching and the teaching of math problem solving. The aim and basic features of the collaborative learning environment, well, the overall aim was to guide and support upper primary school students in becoming more motivated, strategic, communicative, mindful, and self-regulated solvers of math problems. And the general aim can be specified in terms of 3 sub-goals: acquisition by students of, supported by the teacher and knowledge forum, of a 5-step strategy for the teaching, for solving problems. Then developing in pupils positive beliefs and attitudes toward learning math and math problem solving. And acquisition by students of collaboration, and communication skills in problem solving using the technological tools. Key features of the learning environment were use of a varied set of non-traditional, complex, realistic, and challenging problems that elicit and enhance the application of cognitive and metacognitive strategies. And I give you hereby an example of the kind of problems we used. So you see here a strip figure, which we called Fix-It. And the problem is as follows. I've got a new problem of the week for you. Did you read the newspapers last week? Well, if you did, you probably have read the news about the huge traffic jam last Monday. On that day, there were several traffic jams due to a strike of the railway workers and a severe car accident near Brussels. When a jam gets really long, we normally speak of a monster jam. On the picture below, and there was a picture given of the road, we normally call it, on the picture below, you can see such a really long monster jam. On the highway from Ostend to Brussels, there was an enormously huge traffic jam, 25 kilometers long at a given moment. I was wondering how many vehicles were in that traffic jam. So this is a very open problem, as you can understand, which involves that you have to make some assumptions, and discussion can have, and there is no only one solution, there are maybe 50 solutions that can all be realistic. So that's the kind of problems we used. The second characteristic of the application of highly interactive and collaborative instructional techniques, creation of a fundamentally changed classroom culture based on new socio-mathematical norms for how you work with the students in the classroom, and gradual removal of the external regulation by the teacher in favor of self-regulation by the learners. Some specification of an implementation of the learning environment, but I will have to be fast here, I think, because of the time. So there were 4 phases. And the first phase was mainly introducing them to the approach to problem solving and to the software tools. Then the second phase of 3 weeks, they solved problems in groups. These problem solutions were brought into the into knowledge forum with their solutions and the important solutions, but also their solution strategies, not only the solution, but especially the solution strategies. And this was then an open discussion in the classroom about the different solutions of the different groups, because they worked in small groups of 3 students. Then in the third phase, what was then done, they continued to work on the problems, and gradually the support was withdrawn. And then I will be brief on the fourth plan. In the fourth phase, they were asked to generate problems themselves. And another group had to solve their problem. They had to solve a problem of another group. And there were also guiding the other groups if they had problems. So there was a lot of communication between the groups on the problems that were generated by the students themselves. And again, this was ending with a discussion in the classroom. So it was in 2nd, 5th and 6th grades. Computers were available, and I will skip this and say something about the results. We used a lot of instruments to look at the effects of the environment, like tests, questionnaires, interviews, observations. And the results were a bit mixed in some way, because there was a significant positive effect on the problem-solving competency of 6th graders, but not of the 5th graders. Questionnaire data revealed not very much positive impact on their pleasure and persistence in solving problems and on their beliefs about problem solving, but the environment yielded a significant positive effect on students' beliefs about and attitudes toward collaborative learning in general and toward computer-supported learning in particular. So the data, I will skip this a little bit also, the data of the teacher evaluation forms were also positive because they liked a lot to use this approach, but they needed very much support. And the students themselves were also very enthusiastic. They liked this way of doing word problems much more than the traditional approach, and many of the students reported also to have learned something new about information technology and about math problem solving. This is an article in a Flemish newspaper that was published about the project where it said, nothing more fun than a good problem. So they really liked to do it. Okay, maybe I will skip this because of the time, and I will go, this was what I intended to do about the MOOCs, but I have skipped this. But I can refer you to this book, a recent book published just a few months ago, From Books to MOOCs, Emerging Models of Learning and Teaching in Higher Education, which comes out of a conference last year of the Academie Europea in Stockholm, and I co-edited the book with Lars Engwall and Ulrich Teichler. So it's very recent and gives a good state of the art. Well, let me give some final comments. No doubt technology can make a substantial contribution to the innovation and improvement of educational practices. However, it is obvious that the high expectations that rose in the early 1980s have so far not been realized. And this was recently again confirmed by an article in the American magazine Education Week from June 16, 2-3 months ago, the conclusion of a survey that they did with 700 classroom teachers and school-based instructional specialists, teachers still struggling to use technology to transform instruction. However, over the past years, the educational technology and the educational research communities have become more and more aware of the weaknesses of past applications of ICT, and in this respect, several recommendations can be put forward to make progress. First, a radical shift is needed to the learning-based approach from the technology-based approach, based on constructive perspective of learning and considering technology as an aid and support for learning, integrated in the learning environment. Second, implementing this approach should be supported by high-quality research. In this respect, especially learning design research, aiming at the development and evaluation of novel, collaborative, technology-supported learning environments. And in terms of Stokes' definition of the quadrant model of scientific inquiry, such design studies can correctly be situated in Pasteur's quadrant, which represent use-inspired basic research that on the one hand contributes to the advancements of our theoretical understanding of the process of learning, but also to the innovation and improvement of practices, which is the same idea behind the work of Pasteur. Third, in line with the recommendation of the survey to which I referred, it is necessary that substantial attention is paid to the training and professional development of teachers. This is very crucial. The survey recommends that all countries make ICT a compulsory component of initial teacher training and argues that, quote, evidence shows that increasing professional development opportunities for teachers is an efficient way of boosting ICT use in teaching and learning, since it helps build highly confident and positive teachers. But even if teachers have access and positive attitudes towards using ICT in their classrooms, they often still need technological as well as pedagogical guidance and support to make progress in the field. And in this direction, it is important that schools dispose of ICT coordinators who have sufficient expertise to provide the necessary support. And will we be able to make progress? Yes, we are confident of ourselves. Thank you very much. Grazie.
Thank you to Professor De Corte, because you gave us a lot of hint you have to reserve on, but due to the late time, I suggest to contact the two speakers at the coffee break for other questions. Thank you very much.